Hi everyone, welcome to Our Tech Talks podcast, and this is Kashi from Our Tech Talks podcast. Today is our third session on Concurrent Processing Server of Oracle eBusiness Suite. The objective of this podcast to cover different Oracle technology products, tips and tricks, troubleshooting techniques, real life examples, and a lot of more stuff on Oracle, which we are doing in our day-to-day professional life. The notion is just to share and learn with Oracle users community. In today's session, we are going to talk on Concurrent Processing Server in Oracle Business Suite, and we will be covering what is Concurrent Processing Server, what are the concurrent requests and managers, where should eBusiness Suite Concurrent Manager be located, key characteristics of Concurrent Manager, specialist concurrent managers, setting up concurrent managers, what is the concurrent request lifecycle, concurrent processing architecture, how concurrent processing works, viewing concurrent processing output, what is parallel concurrent processing, and how to manage concurrent processing. And the last will be concurrent processing and online patching. I believe with these 13 points, we will be able to cover entire and complete process and architecture behind concurrent processing server, a very essential and mandatory part of Oracle eBusiness Suite architecture. And for detailed understanding for any Oracle professional who is going to work on Oracle Business Suite technology, it should be very clear and understood what is the concept behind concurrent processing server. So let's start with that. Usually, user interactions with Oracle eBusiness Suite data is through HTML based application or modules which we use to access on eBusiness Suite, or the traditional Oracle form-based application which were based on Oracle D2K forms, we used to call them in old age, and mainly all data is being entered through these HTML-based or Oracle form-based modules. However, there are also reporting programs and data updating programs that need to run periodically or on an ad hoc basis whenever user want it. These programs, which run in the background while users continue to work on other tasks, are run using the concurrent processing architecture. So any report which is being run by Oracle user, or he want to generate report, that is a backend process while he will be working on entering any data on the front end form. The backend running of concurrent requests, that is being managed by concurrent processing. Concurrent processing is an Oracle eBusiness Suite feature basically that allows these non-interactive and long-running functions to be executed alongside interactive operations. It uses operating system facilities to enable background scheduling of data via a set of programs and forms. To ensure that resource-intensive concurrent processing operations do not interfere with interactive operations, they are run by a specialized component, the concurrent processing server. The server is located on the Oracle eBusiness Suite application tier. However, we can also set up a dedicated concurrent processing server based on our architecture design or a requirement when we will be sizing our solution for any organization or for any customer. Our second topic was what are the concurrent requests and managers? What is basically behind these terms? Processes that run on concurrent processing server are called concurrent requests. So any process which will run, which we used to call as concurrent request. So this is a one report which we submit in Oracle Business Suite that's called as concurrent request. When we submit such a request either through HTML based or form based application or form based module like Oracle Purchasing or Oracle Payables, General Ledger, a row is inserted into a database table specifying the program to be run. A concurrent manager then reads the applicable request in the table and starts the associated concurrent program. So the concurrent manager will take that concurrent request ID and then it will start running it. Where should eBusiness Suite concurrent managers be located? Traditionally, the concurrent managers were installed on the same machine as the database, and there were understanding that placing concurrent processing services and the database tier on the same node will improve performance. This was an old architecture or old way of doing Oracle eBusiness Suite installations. However, with the much faster local networks that are now common and available in any organization in any country, and the typical co-location of database and application tier machines, it is generally preferable to run them on a separate machine. If we have a very heavy, quite intensive concurrent request to be run on our Oracle Business Suite, this greatly facilitates ease of management and maintenance as well as providing deployment flexibility. However, as per Oracle recommendations, there is no significant performance benefit to placing concurrent processing and the database tier on the same node. Our system will be more scalable if database tier hardware is dedicated solely to serving the needs of the database. Patching, cloning, and eBusiness Suite administration will also be much easier as we will have at least one less Apple top and application tier technology stack to maintain, because there will be no application Apple top on the database tier. Placing concurrent processing on the database tier node to distribute load management or loads might suggest that our application tier hardware is already undersized. We should place concurrent processing on the same node as our web form services, or if we want, a separate dedicated concurrent processing tier where we see it that there is a very busy environment and we will be having a very heavy concurrent requests. Otherwise, it is advisable, suggested by Oracle, that we should have a concurrent processing server on the application, on the apps tier where our forms and web services are. Key characteristics of concurrent manager. Now, concurrent managers are fundamental to concurrent processing, acting as a job scheduling and executing system. A concurrent manager is an executable that is registered as a program library within Oracle Business Suite and which runs in its own operating system process. There are different terms being used in this architecture. So, for example, what is target processes? You will see a target processes. Target processes runs operating system processes called target processes, often referred to as workers, each of which can start one concurrent program at a time. The next term is commonly immediate program. So what is immediate program? Can optionally run an immediate program that runs as part of the concurrent manager's own operating system process. A concurrent manager can be allowed to run any concurrent program or be specialized to run certain programs. So we can even fix that one concurrent manager will run only specific programs which we want to run based on any of our modules, or maybe we created some custom program which we want that it will be run by a specific concurrent manager. A concurrent manager operates during the days and times defined by a work shift. Our next point is specialist concurrent managers. What are the specialist concurrent managers? There are a number of specialized concurrent managers. Number 1, internal concurrent manager. Number 2, conflict resolution manager. Number 3, standard manager. Number 4, transaction manager. Now let's go through one by one. The internal concurrent manager, we used to call as ICM, controls all other concurrent managers. So it's a main manager which will control all other managers. It administers the startups and shutdown of manager as defined by their work shift. It monitors for process failure and cleans up if failure occurs. The internal concurrent manager does not process concurrent requests itself, except for a queue control request such as activate, deactivate, or abort. Without modifying ICM definition, if required, we can modify the sleep time. Now, the next term is, what is the sleep time? A Sleep time. What is sleep time? A sleep time number of seconds in the ICM waits between checking for new concurrent requests. Another term is cycle time. What is cycle time? PMON, process monitor cycle time, number of sleep cycles the ICM waits between checking for failed workers. That's called as cycle time. Another next term is a queue size. What is a queue size? Queue size, duration between checks for number of active workers measured in PMON cycles. So these are different three terms which are commonly used in sleep time, cycle time, and queue size. I hope that I'm able to clarify it. The conflict resolution manager. The next manager enforces rules designed to ensure that incompatible concurrent requests do not run in the same conflict domain. As with the internal concurrent manager, the basic conflict resolution manager definition should not be changed, but we can modify the sleep time for each work shift as well as some parallel concurrent processing options. So these options are available, but this usually CRM is used to avoid any incompatible concurrent requests. Next is the standard manager. In Oracle eBusiness Suite, standard manager will accept and run any concurrent requests as it has no specialization rules that would restrict its activities. Therefore, the definition of the standard manager should not be altered without careful planning. Otherwise, some programs might not be able to run at all. Jobs should only be excluded from the standard manager after ensuring they can be run by any alternative manager, such as product specific manager or user defined manager, which we usually define it. Transaction managers. Transaction manager supports synchronous request processing, whereby a pool of server processes response to requests from client user programs. Instead of pooling the concurrent request table to obtain instructions, a transaction manager waits to be signaled by a client. An example is approval of an order where execution of the request must take place quickly. Setting up concurrent managers. Some of the key steps for setting up and monitoring concurrent managers are name and description of the manager, assignment of a concurrent program library, assignment of work shifts to the manager, definition of the maximum number of workers, target processes the manager can run concurrently, optionally specializing the manager to run certain types of requests. So these are the setup for the setting up for the concurrent manager. What is the concurrent request lifecycle? A common lifecycle of a concurrent request consists of 4 phases. We can go through one by one. If the phase is pending, then it means the request is waiting to be run. If the phase is running, then the request is running. If the phase is completed, the request has finished. And if the phase is inactive, the request cannot be run. Concurrent processing architecture. Programs are run as operating system background processes. These programs can be written using number of Oracle tools or programming languages. For executables are the host operating system script languages. Another key concept is what is immediate program. A concurrent program that runs in the concurrent manager's own operating system process is known as an immediate program. Immediate programs run as a function within the concurrent manager's program library. Examples include PL SQL programs. What is spanned program? A concurrent program that runs in a child process of the concurrent manager process is known as spanned program. Examples include SQL programs, SQL loader programs, Oracle reports, C programs, and host language programs such as Unix shell scripts or Windows command files. All reports are run through the concurrent processing server manager via the RW run executable, which spans an in-process server. A concurrent program library contains concurrent programs that can be called by a concurrent manager. An important example is the Oracle Application Object Library, which we used to call as FND-LIBR, which contains Oracle eBusiness with immediate concurrent programs and is assigned to the standard concurrent manager. Our next topic is how concurrent processing works. Internal concurrent manager controls all the other managers. It must be running before any other manager can be activated. Once the ICM has been activated, it starts a service manager on each node that is enabled for concurrent processing. Acting as an agent of the ICM, the service manager starts the concurrent managers on its node, excluding any managers that have been deactivated or that have no current work shift. The ICM can be activated and deactivated from the operating system prompt or Oracle Applications Manager. It can also be deactivated but not activated from the administrator concurrent manager's form. When the ICM is initiated on Unix, the fnd_top/bin/start mgr program is invoked. So what it will do, this will call fnd_top/bin/batch mgr, and then it starts a shell process, start the ICM process using the command fnd-libr, which starts parameters fnd, cpmgr, and fndcmbr. The third point is creates log files like std.mgr and wnn.mgr in Apple CF and Apple log file. Normally, start mgr is run by the user account that owns the application software, for example, APPLMGR. This account must have a write privileges to the log and out directories where the log and output files respectively are written. How we can view a concurrent processing outputs. The output from a concurrent processing job goes through several stages before being displayed to the end user. The concurrent processing server communicates with the database server via Oracle Net. That's the number 1 point. As a sequence flow. Number 2, the log or output file associated with the concurrent request is passed back to the report review agent, also known as the web review agent. On the third step, the report review agent passes a file containing the entire report to the form services. The fourth step will be the form services pass the report back to the user's browser on a page at a time. What is a parallel concurrent processing? PCP. PCP allows concurrent processing activities to be distributed across multiple nodes in a real application clusters environment or similar cluster system. By distributing concurrent processing in this way, hardware resources can be fully utilized, maximum throughput, and providing resilience to node failure while retaining a central point of control. So that's how parallel concurrent processing helps us. Parallel concurrent processing also facilitates us to run concurrent processes on multiple nodes to improve concurrent processing throughput, continue running concurrent processes on the remaining node when one or more nodes fails. Parallel concurrent processing is enabled by default, so PCP is always available for use in environments where one or more concurrent processing nodes exist. How to manage concurrent processing? From the command line, 2 commands can be entered to control the internal concurrent manager: start mgr, which starts the ICM, and concsub, which is used to stop or abort the ICM, or request the ICM to check on the operating system process for each manager. Other option is autoconfig enabled environments provides a number of scripts for starting and stopping application TS services from the command line. You must be aware about that one. When we are starting a new Oracle eBusiness apps tier, then there are scripts available. The scripts for concurrent processing startups and shutdown is, if you will go to inst_top/admins/scripts/adcmctl.sh. So this is a script which is used in autoconfig enabled environments, which is commonly available. The various components of the concurrent processing system can be managed from various forms. We can manage through the concurrent manager form like an administrator, or from a concurrent manager or a concurrent request under Oracle Application Managers. Now, with the release of new version 12.2, how the concurrent processing and online patching works. The introduction of online patching with release 12.2 has involved the introduction of a new concurrent program, ADZD patch, to ensure that concurrent programs cannot run during an online patching cycle if they are incompatible with the new patching model. We will be discussing this in detail when we will cover our online patching topic. Now, for today's session, the last topic is tricks of the trade. Based on experience, I can tell you number one, concurrent processing database tables. We should be aware about it. What are the basic tables are behind the scene? FND underscore concurrent underscore requests. Details of user requests including status, start dates, and completion date. Second table is FND underscore concurrent underscore programs. It will give us details of concurrent programs including execution method, whether the program is constrained and whether it must be run alone. Third table is FND underscore concurrent underscore processes. Cross references between concurrent requests and queues and a history of concurrent managers processes. Fourth table is FND underscore concurrent underscore queues. Information about each of the concurrent manager queues. Number two, tricks of the trade. Truncate that reports.log file in log directory. This is very important. Truncation of the file reports.log is a regular maintenance work of application DBA. We should make sure that reports log files should not be increased to its maximum limit of 2 GB. There's no separate purge program to truncate file reports.log. This maintenance needs to be done manually and regularly depending on the number of concurrent program which uses reports.log. We can safely truncate reports.log. The reports.log file can be located under Apple CSF /Apple log. Number three, we should ensure purge concurrent requests and our manager data is run at regular intervals with the following parameters. This will purge the old records on the concurrent requests and the manager data. The parameters we should be using with the entity parameter as all, a high number of records in the FND concurrent tables can degrade the performance. So if you're facing some issue on the performance, then you should check purge concurrent requests and or manager data. Number four, we should ensure that the log and out files are removed from the locations shown as we run purge concurrent request or manager data program, and the locations are Apple CSF /Apple log and Apple CSF /Apple out. So we should remove these files from the locations. Number five, if you are facing some issue on an overall concurrent processing or concurrent manager, there is a CP analyzer for Oracle eBusiness Suite. Concurrent processing analyzer basically is a self-service health check script which reviews the overall concurrent processing footprint, analyze the concurrent configurations and settings for the environment, and will give us feedback and recommendations on best practices. So this is a very, very excellent tool introduced by Oracle support. For reference, you can check my Oracle support doc ID 1411723.1 concurrent processing CP analyzer for Oracle eBusiness Suite, and I will also put in the show notes. And if you are an expert user and you know the queries and commands everything, then we can refer my Oracle support document ID 1499538.1, and it will give us all the queries which are used behind concurrent processing CP analyzer program, CP analyzer tool. So it will give us all the queries behind that, and we can review those queries. With this, I would like to summarize today what we have covered. We have covered what is concurrent processing server, what are the requests and managers where we should place Concurrent Manager, what are the key characteristics of Concurrent Manager, what are the specialist Concurrent Managers available, how to set up Concurrent Manager, what are the concurrent request lifecycle, what is the architecture behind the concurrent processing, how the concurrent processing works, and how we can view the output file, what is parallel concurrent processing, and how to manage concurrent processing. And the final, we reviewed the concurrent processing and online fetching. With this, our session is done. And please, you can refer show notes on www.otechtalks.tv/session3. All the information and reference notes will be available over there. Thank you very much for joining today's session. And please join us on otechtalks.tv and be part of Tech Talk.